Okay,
So,
No, she didn't tell you that she to get this out.
if you would get this sheet, thank you. Yeah, this sheet with the double angle identities on it. Also have your memo page handy for us to add a few more things to it. Remember the notation that I gave you, that most of you probably meant on your memo, put on your memo page? Where it goes sine plus or minus AB,
Yes.
goes sine A, cosine B, plus or minus cosine A, cosine, I'm sorry, I gotta start at the beginning like the alphabet. Sine A, cosine B, plus cosine A, sine B. And I'm only making this yellow because of the dog's ear. Okay, sine B. When I got to cosine, I said cosine A plus or minus B, but I wrote it as cosine A, cosine B, and if you're following the plus one, it would be minus sine A, sine B. If you're following the minus one, it would be plus. So did everybody understand that notation? I was going really fast, okay?
Yeah.
On a memo quiz, make sure you follow whichever one I've given you. Okay, so one thing I wanted to show you was, I've already shown you this. If you found like the sine of 15 already somewhere on your sheet and the cosine of 15, by the time you got to tangent of 15, you have the choice if you wanted to memorize this tangent A plus B and A minus B formula and do it with the fractions. And let me oh, by the way, if you found sine of 15 and cosine of 15, you can use another identity and just always put sine over cosine for me, okay? I make you memorize things because if they're not in your head, you're not even gonna think of them when you need to later on in my class and in calculus, okay? So you gotta memorize them. It's like if you never memorized 5 plus 2 is 7 or 5 times 2 is 10, every time you saw it, it'd be foreign to you, and you'd fall behind pretty fast in whatever course you were in. And there's actually, students I've had that apparently didn't learn their multiplication tables or not very good at subtracting. And ironically, many times they've gotten pretty good at math, but they just weren't paying attention for so long that some of the easy stuff is harder for them than some of the new stuff. Anyway, so sometimes that happens. I don't want it to happen to you. All right, now I wanted to show you this. I'm not sure I showed you the other day. Tangent of 15, you could have done 45 minus 30. When I was in a real big hurry the other day, I told you if you're gonna do the tangent formulas, it's better to do 60 minus 45. The only reason for this is tangent is gonna be a fraction if you choose to use the formula, which you'll read right off of here when I apply it. I wanna say really clearly, you don't have to use the formula for tangent ever. If I ask for tan of 15 or tan of 75 or tan of pi over 12, one of those things, you will have already somewhere on your test or quiz found the sine and cosine. You can go back up and click on those. All right, but anyway, just pay attention. The reason I would rather do 60 than 30, if I'm making a decision, this one goes tangent A minus tangent B over 1 minus tangent A tangent B. All right, if you did this one, sorry, let me see if I can get it to extend page.
You have to stop using this excuse or anything.
Oh well, I'll squeeze it down here. If you did this one, it would be tangent of 60, which is square root of 3, minus tangent of 45, which is 1, over 1 plus tangent A, tangent of 60, which is square root of 3, times tangent of 45, which is 1. Order of operation, you multiply first, so you get this. There are some classes and some teachers that would make you do what's called rationalize that. And I don't even know if you remember how to do that. You probably didn't do it very much in algebra, but you would multiply by something called the conjugate, which we'll talk about more later. Here though, the reason I don't really like this one, if I erase up here to where I can write.
Do we have to rationalize with the triangles?
No, you don't for me, but just kind of follow whatever your teacher makes you do. Tangent of 45 is 1. Tangent of 30 is root 3 over 3. 1 minus, plus, this is plus, girls, I'm sorry, tangent of 45 is root 3 over 3 times 1. Do y'all see why I would rather use tangent of 60? Because I have no fractions in my fractions. I want to allow that. I want to allow you to leave a complex fraction, which means a fraction in your fraction. So to fix this up, I would multiply by 3 on the top and 3 on the bottom. That gives me 3 minus square root of 3 over 3 plus square root of 3. So here's one person's answer that might have used 45 minus 30 that takes a little more work. Here's another person's answer that used 60 minus 45 that took very little work. But even less work would have been to put your sine of 15 over your cosine of 15.
And then that gives you
Square root of 6 minus square root of 2 over square root of 6 plus square root of 2.
okay.
And if I took time to punch this in my calculator and this in my calculator and that in my calculator, they'd all be the same decimal.
Right.
Okay? So we've all found the tangent of 15.
Got it.
So I've got to grade it whichever way you worked it, okay? The reason you have your sheet out though is I'm going to write down all of the problems. By the way, this friend of mine, I taught honors pre-cal and AP calculus, AB. But I'd forgotten that. We've been friends so long. I just like, oh yeah, I was your teacher one time. Anyway. So sine of 15, tangent of 15. Okay, so we have sine of 15. Then you had tan of 15. I'm going to skip. Well, I'll just write it down. Tan of 15. Cosine of 105. Sine of 105. On the second page, you have cosine of 75. Sine of 75. Tangent of 75. Cosine of 165. Sine of 165, tan of 165, and cosine of 195. I didn't put that one in parentheses for any big reason. All right, girls, please watch. Because I think on my tests and quizzes, you always want to be as efficient as you can so that you have time to maybe go back and check some other things. What I'm about to show you may be kind of nervous to do on a test, but I'm trying to think if I want to go in and give you the other identities first. I think I will. I'll come back to this in a minute. So now you'll see why I'm coming back to this just a second. I just thought of something else you don't have yet. So get out your memo page. We're almost through actually with writing on your memo page.
Mine's very cramped. I'm gonna have to like put it on another.
Mine's like
rearranged.
I'm terrified for the math fun because this is what I'm writing on my note card.
But it's memorized.
Thank you.
We don't want me to write the charts.
I don't need to write any of this on my note card because you just pretend you're taking a memo quiz.
Hey
Yeah,
girls,
you just do it at the
the
beginning.
math department,
Yeah, but like this entire.
of which I'm really not a part of the discussion, is they're batting around what you're allowed to write on your note card and what you're not. So don't plan ahead too much because they may have things that they veto or accept and I'll have to abide by that. The reason I'm not part of the discussion is there's nowhere on any planet when I taught before and gave an exam that I would have let you have a note card. So here I am at Marymount and they give out note cards for the math exam. So anyway, I don't really care what they decide because I wouldn't let you have one anyway. So it doesn't matter to me. I'd be more strict than whatever they decide.
Are we
So.
not going to be allowed to write like our, I guess,
I don't know. I just hear this talk and I think I'll just wait because I'm in the middle of writing exams. Y'all's is pretty much done, but and I'll give your review sheet probably next week, most likely.
It's in less than a month.
Okay.
Next
Anyway,
month is March.
watch this.
What?
Yeah, and then Rarely has all their finals in
But
March,
all
and then
of
they
them
have
big
projects
end
at
of
the
year
end of the
tests.
year.
I hate projects.
I don't like them
Also,
either.
yeah.
I'd rather just have a test and get it
I
over
think
with.
it's good they have finals because then when we get to college, like, we're not gonna be.
Yeah, we're not gonna be like,
Oh,
my
and
God.
we always had semester finals. I mean, I
Yeah.
like
Yeah.
always Well, not really, the end of a semester, like in college or
I
classes.
already have midterms.
But I mean, when, I've never taught at a high school that didn't have Christmas exams.
We have those, but it's not like, it's not like a
They're
whole
just
exam,
that
it's
I
just
get
like,
on my
Well,
midterms.
they're usually whole exams.
Christmas is always like rapid fire.
I kinda
I
wish,
studied
like
too.
last year for our history
Us,
class,
this
there
wasn't
was so
really
much
cool
on
ear
it, I wish
sketch
that we
for
just
like
had
2
one and
months.
end
I was
with
like,
the
this is not
experts.
ear sketch.
We only do
Your
2
sketch
second
go.
semester.
I know, and
What's
now
an
I'm
ear
like,
sketch?
most of the questions were
We
from
made
like
music.
the exams.
All right, girls,
like
look
the
up at the
EM
board.
grades. That's where like everything was.
What are
Um,
you talking about?
And let's be quiet for a second, okay? Now, if you just looked at this, you would probably say that I have sine x typed into my calculator or some form of sine. Do y'all see what I mean?
Yes.
Okay? It's actually going up 1 and down 1. Can y'all see the period is about 2 pi? 1, 2, 3, 4, 5, 6.28. Okay, so this is just sine x. But look what I typed in. I typed in both of these. Please pay attention. I'm going to turn off the blue. There's the red. There's the blue. There's the red. There's the blue. There's the red. Okay? That's because this has a phase shift of pi over 2. If I'm in degrees, it has a 90-degree phase shift. If I was in degrees, I would need to go cosine of 90 minus x. So there's a reason for this, but you'll write it on your memo page in a little while. Of course, you won't write until I tell you to. But watch this. Tan of x and cotan of pi over 2 minus x. Let me turn on the blue. Watch. Same. Because I've shifted the cotangent over to land on the tangent. Okay? Now listen to the words I've just said. You've probably never really noticed that. I had not until my teacher said these words to me. I just thought sine, cosine, secant, cosecant, cotangent, whichever one I've left out, okay? Because there's 6. I didn't ever realize till Miss White taught me this that it was, I just know a tourist going to come by when I'm on my knees sometime. Anyway, I didn't ever realize it when until Miss White was teaching us the cofunctions that it was sine and cosine, secant and cosecant, tangent and cotangent. And you might wonder, whoa, why'd they even name them that? Okay, it's because they're what are called cofunctions. They're not reciprocals of each other, okay? They were probably named sine, cosine, secant, cosecant, tangent, cotangent, because of what I'm showing you here, okay? And then I bet later on they found out they were reciprocals. Sine and cosine are not reciprocals, but they surely look alike, don't they? Can you see why they would be cofunctions? Don't secant and cosecant look a lot alike? They're those U-shapes. And I could shift one over to be on top of another one. Tan and cotan look alike. Isn't it funny when you hear it and you realize as I was teaching you your graph, I taught you sine and cosine. I taught you secant and cosecant. Then I taught you tangent and cotangent. And even at that, me personally, I didn't notice the words. Because we write our abbreviations. But if we write them out, you realize, wait, they're sine and cosine, like co-presidents, okay, of a club or something. So of course I could put in secant and cosecant and that same thing would be true, okay? So let's put in secant x. And right now I'm in radians. If I was in degrees, pi over 2 would be 90, you know, right up here at pi over 2. Now I'm going to put in CSC. And now I want to shift the blue one over to the red one. So you'll watch, girls. I want to shift the blue one over to the red one. And so I'm going to give it the correct phase shift that I know will work. Did y'all see? Let me turn off blue, red, blue, red. That's why they're called cofunctions. They look alike. In fact, if I gave you this red graph and said write an equation, there'd be a few different things you could write. You could use secant or cosecant and shift it on top of where you want it to be. Okay? All right, so let me go back to our slides and talk about why that is. You're still not writing on your memo page. Tell me other things you may not have noticed. Sine of 30 degrees and cosine of 60 degrees.
Are they equal?
They are both 1/2, okay? Tangent of 60 degrees and cotangent we write it COT, but tangent of 60 and cotangent of 30, those are also the same. They're both square root of 3 over 3, okay? Guess what's gonna happen if I type into my calculator? Well, why don't you predict? What if I take this out, and on a test I said the sine of 10 degrees equals the cosine of blank. No calculator. What would it be? Almost.
20.
No, wait, sorry, what?
80. Okay, because what did you notice about 30 and 60? They added up to 90, didn't they? I don't know why you said 80.
Oh, well, you said close, so then I was like, maybe.
Oh, okay. So she went to 80. Okay,
Oh, but that does make sense. 'Cause
I just thought it was
Yeah.
doubled, that's what I was.
do y'all remember what complementary means?
Yeah.
Yeah, it could look like it was double and we just had the double angle
Oh.
identity. Complementary means they add up to 90.
Yeah.
And do you see the word co? Girls,
Yes.
listen, co-functions, okay, are 90 degrees away from each other. Let's see why that is on top of Amy's dog. So, if I have a right triangle and this is 90 degrees, and this is some number, like let's say 10, then how much does that one have to be?
90,
30.
80, just kidding, it's 80.
80, doesn't it?
Wow.
Because
My
how many
math's not-
degrees
I
are
thought
there?
the triangles add
180.
up to, oh, it
because
adds
you
up
have
to
add
180.
But I already have used up how much?
Yeah,
If it's a right triangle, how much is left for those two?
80.
I've already used up 90.
For
So how much is left for these two? 90.
We're at.
Are y'all with me? Cause there's a lot of
Yes.
like different things happening. So if this one is 20, what's this one? 70. Okay, so if this one is theta, this one is 90 minus theta. Do y'all see? They're
Yes.
complementary, okay? The reason that happens is, watch this. If I call this A, B, and C, I know I usually call it X, Y, and R, but I don't want to right now. What is the sine of 20 as opposite over hypotenuse, right? What's the cosine of 70? Cosine is adjacent over hypotenuse. So these angles are always complementary. Do you have that? And what is the opposite side of this one? Do you see will always be the adjacent side of the other one? See this one opposite? It'll always be the adjacent side of its complementary angle. That's why they're always the same number. Hopefully you grabbed some of that, okay? So what I'm gonna say in the cofunction identities that you'll write down in just a minute is it's easy to remember which ones are cofunctions because it goes sine and what? Cosine, secant and cosecant, tangent and cotangent have an extra special relationship. They're reciprocals and cofunctions.
Is this like a big box that we should write, or is this?
You're gonna have time to, I'm gonna pause after I write mine in so you can decide,
Okay.
okay? So, I'm gonna say sine of theta is equal to 90, don't write anything yet. Sorry, it helps if I write the cofunction in there, don't write anything yet. Equals cosine of 90 minus theta. How can you remember the 90? I showed you that it was like cofunctions. Sine and cosine, then I can say secant of theta is cosecant of 90 minus theta. And tangent of theta is cotangent of 90 minus theta. Now you can make your own decision. I'm also gonna make note to self that this is pi over 2. If I'm in radians, and I don't have to rewrite them all. Now keep watching, you're not writing yet.
So
5 seconds.
it's under
Where
Alexander's.
even is it? Oh, that
Whoa, that was fun.
Okay, look, not this, just this, thank you.
You threw me in there.
Well, she threw it like this, and it
Yeah.
went.
Are y'all throwing things back there?
I didn't do it until. She did.
We're throwing candy,
It's
okay.
mints.
She was just passing it on over here.
All
Also, I
right,
think there might be
now.
one on the whiteboard over there.
Like
Is there one
Ava
on the
was
whiteboard?
asking me, someone may have a bigger one. They may then say cosine of theta is the sine of 90 minus theta. and so on and so forth, ... okay? Girls, I'm not a proponent of this big, huge one. Please listen. I hope that you realize if I say sine is cosine 90 minus theta, that you also know cosine of theta is 90 minus, they're cofunctions of each other. So I hope you can read it that this statement also means this statement. Okay? Like y'all figured out, if this one's 30, this one's gotta be 90 minus 30. Either way you do it, okay? But if you feel like you've gotta write this piece over here, what would the next piece be? What if you have cosecant
equals
is secant of 90 minus theta? They're co-functions of each other. And cotangent, if you happen to have that one, it's tangent of 90 minus theta, unless you're in radians. All of these are pi over 2. So make your own decision of what you need to write down for co-functions. These will not show up on your memo page yet. I suggest writing this down on your memo page myself. I think it's going to remind you of what you need. But if you want the blue ones, that's okay with me.
How much more money is more things?
I tell you what, I know this is maybe a cop-out on your question, but I'm afraid to say, just because I don't want to make you plan incorrectly. So there is an entire memo page, Katie Opola's is up on your
So just
topics.
Okay.
So you can look and see how she's got it all on one page. But not a whole lot more, Kate, like
Yeah.
Did you see that?
Yeah, what was
I have no idea.
I know what happened.
Fell from the
But it was like big.
What was that?
There's
Well, there's a
trash
high,
bag.
high wind. Y'all write your stuff on your memo page.
This is how I got sick last time. Because the wind was like killing me. You could hear it in your ears and it hurts.
Yeah.
And I couldn't bring them
The
to me.
people are having trouble walking out there.
Should I
Hopefully run
go
stairs.
swimming?
Actually, why would I ever
Should I
swim?
go
Yeah,
swimming?
Stairs is worse.
But stairs is like chiller because we're like done
I
in an
think
hour.
swimming today could be dangerous.
Have y'all written on your memo page yet?
Should we ride the 5?
I think you'll be safe in the pool.
Wait, what is the one when it's like sign and then there's like a little blue line? Is that important?
No, here, let me get rid of this. This little line?
Relax. Yesterday my piano teacher told me I was too tense to the point that it interrupted me from doing day-to-day things.
Do you that weird man as your piano
No,
teacher?
she says, you're so tense, like tense to the point where you like run into things and knock everything over. It's like, I'm sorry, okay? And she told me I needed to relax to make my life easier. It's like, I'm doing my best. Okay?
Did you cry?
No. You know, I actually have cried 0 times in school. Actually, no, I've cried
That's
more
not
times.
true. You
That's
cried in
not
this
true.
That's why I
class
just
over
remembered.
all students'
Yeah.
calculus take.
We don't need to talk about that. That's the only time I think I've cried in school this year. To be honest. And last
Wait,
year
that
was-
says cosine on the top left.
Yeah.
I've
And
no,
then
I cried
cosine.
one
Sine,
time.
it's, here are the words, Ava,
Yeah, but that was like
sine
for
and
with social
cosine.
purposes. That was like
Yeah.
Secant and cosecant, tangent
That's
and
compared to last year. I
cotangent,
cried
so that you write
uncountable times.
I cried
Like,
so much
I
over
swear to
time.
God, you for 2
Like I used to
That's
feel
right.
I
all
think
the
I'm
time
like
photos.
emotionally repressed
Yeah.
because I haven't
I
cried.
never
Emotionally repressed.
I can listen to country music and cry usually if I really need to cry.
Oh
No,
my
but
god,
I
there's a
like I
really
can't cry. Like
Yeah,
I
I don't
like if
cry.
you make me sad, then I'll just be
Yeah.
like,
Oh,
I'm
that's
mad at
sad.
you now.
I stress cry a lot. I
Yeah,
don't
me
do
too.
sad
I'm
cry.
not a
I
big
stress
crier. I
like
cried
that.
when I signed
I'll
up for
feel
the
I
March
hate-
SAT.
One of my
started
biggest
crying all the
fears
time.
is crying in public. I hate crying in
Well,
public
then
more
you
than
can't
anything.
stop. It's like laughing in public.
Oh my god, my NPAC last year. We started laughing.
my
we could not
God.
stop.
My
It was
stress
so
workout
bad.
That was
is
so
like,
uncomfortable.
I have to run.
That was
That's
so
like
Instead of
uncomfortable.
cry.
That's like a good thing though. Then I would just be, I would be
I'd
very
be
fit
running
if
all the
I
time.
was
During
stressed, if I
final
worked
season,
out every
I'm
time
like
I'm
a
stressed.
Oh no, actually, Sam. During finals.
Have y'all written your
Yeah,
co-function?
yeah, we're just making the box
No,
now.
I
During
haven't.
before the math final last year, we don't need to talk
Should
about
we
the
write
actual-
the
And then I get a
one?
fever.
But before I
This
actually
is there. Should we
spent
write the one
entire,
and
like,
pi over 2 part?
weeks, 2 weeks in
I
advance.
would write that in so you remember if you
It's
see it in radius.
It's
And then when
Okay,
it
we're
came
gonna do it.
See, when
Yeah,
I
you know
cry,
what,
you know it's
yeah.
bad because like I don't give
Hey,
myself the
don't
time
talk
to cry.
if you haven't written. You're not allowed to talk unless you've written this on your page.
Okay,
I
I'll
promise I
written
wrote
it.
that.
Oh, is anybody doing speedball?
No, I signed up for
I think Grace
choreography.
does.
It's the PE sport,
signed
but
up
I don't
for
even know what
varsity
speedball
Why
consists
aren't
of.
you doing varsity lacrosse?
Because I
Why are you doing
choose
fruit?
six. One, my arms can't like throw. It's just
Okay,
a
so
It's not that hard. You just go
Have
like
you got
tap
a
with
cake?
the stick. Yeah,
Right.
but
Like,
why don't you do that?
Ava, you still
It's not the
running?
musical, but
I'm
I'm gonna work out
sorry.
this
I
like I did last year.
What'd you do?
Or it was like I joined the team after. It's just what I'm gonna do.
Okay.
Virtual magnet.
Now, why did I want to do that first?
I'm so
So watch. Quiet.
This laser thing hurts my head.
We are getting a.
Okay, so what does the sine of 15 degrees equal the cosine of what?
90
minus
So it was like I'm out.
15. Cosine 75.
Oh, so you can just solve it like.
Hang on just a second, you're on the right track, okay? But do y'all see what I mean?
Yeah.
Okay, so
so
that's
nice.
why I did that. So now I'm gonna go back to this slide.
The epitome of.
Girls, this very important slide that I would never have told you before because I wanted you to do every single problem so you help you memorize identities. But sine of 15, I think you got square root of 6 minus square root of 2 over 4. Tangent of 15, hopefully you got from the fact I had cosine up there. And so tan of 15, I didn't really have to work out. I put sine of 15 over cosine of 15 and did keep, change, flip. Now stay with me. Let's see, sine of 15 is the same as cosine of 75 because I just taught you your cofunction identities. If the angles add up in degrees to 90 and you have sine and cosine, I bet if you check your cosine of 75, you had square root of 6 minus square root of 2 over 4.
Yeah.
The sine of 75 was the same as the cosine of 15. The cosine of 15 was the square root of 6 plus the square root of 2 over 4. Now let's talk about the 105s, okay? 105 degrees is right here. Please watch. It'll help you a lot. 105 degrees is right here. It is 75 degree reference angle. So if you already have found somewhere on your page the sine of 75, then you also know the sine of 105, which is not up here. Oh, these are the same. Sine of 75 and sine of 105, are those the same thing on your homework sheet? Look at it and see. Sine of 105 is number 4. Did y'all get that for number 4? Check and see, sine of 105.
The 2 plus.
You should have gotten this.
I got square root of 2 plus square root of 6.
Yep.
Okay,
Yeah.
so that's a yes.
Yes.
Okay, but girls, I didn't even work number 6. Number 6 is the sine of 75. Those are the same things. Y'all see these reference angles that you weren't noticing before?
Yes.
Okay, so you can shortcut your work if you are confident with some of this really intense trick. All right, now let's go to 165. 165 has what kind of reference angle? 15 degrees, okay? So the sine of 165, girls, is the same as the sine of 15. By the way, if you're commenting going during this, I strongly suggest you find this slide and start at the beginning of it on the video, okay? Anyway, the sine of 165 is the same as the sine of 15. To start talk about that again, here's 15 degrees. If I go to the sine of 165, that's also 15 degrees. They have the same angle, and what sign in the first and second quadrant is positive. What about the cosine of 165? It would be the same as the cosine of 105. Look at those. Here, I'm sorry, it wouldn't be 105. 165 is right here. That would be the same as the opposite of the cosine of 15. So you can play that game as much or as little as you want. But it's interesting to see, if you get in a hurry, it's really nice to notice all those relationships. I'll speak about it again before we have it on a test or a quiz. All right, now I want you to add something else to your memo page and also have your homework out in just a second. Another thing to your memo page, like I say, we're getting close to the end. All right, right now you're not writing. You're just gonna get this on your memo page.
Is it a lot or a little? I have to redraw mine.
You're gonna have to just wait until I put it on.
Okay.
Then you make your own decision,
I'm not
okay?
fully exclusive.
All right, now, you're just watching me develop. You're not writing. Sine A plus B equals sine A cosine B, you already know this, plus cosine A sine B. There comes a time in calculus and in my class actually in pre-cal where you need to know the sign of what's called a double angle. Do y'all see why I'm doubling the angle? Okay? I did another one a second ago where they were co-functions, they were complementary. You don't really know why right now, but you sometimes have to know the double angle identities. So the way people got these is the double angle, they made this watch. They said, oh, if it's the same angle, then I just have A plus A. Do y'all agree with that?
Yeah.
It's like the sign of 10 plus 10 instead of just the sign of 10 plus 20. Please watch. Y'all see what I mean? So the angles are happen to be the same. And so every time I have a B, I change it to a what? A. Good. So what I mean by this is if this is sine of 30 and 60, that would have been sine of 30 cosine of 60 plus cosine of 30 sine of 60. But if they're both the same, it's just sine of one, cosine of the other, and they're exactly the same. Oh, sorry.
Yeah, I just didn't get it.
Okay, now, what do you notice about those two?
They're gonna be the same.
So I have two of those,
Yeah.
okay?
Oh,
'Cause-
so it's
so it, no, they're added.
two.
So it's 2 sine A cosine A. Okay? Now, do y'all agree that's 2A?
Yes.
Yeah.
Now, I hope none of you would think about this. We talked about it last class, that would be true. That is not true. I think some of you realize about the order of operation. We talked about PEMDAS. There's no way I can pull this 2 out in front. We're not going to try it right now in interest of time, but if you tried this and typed in like the sine of 2 times 10, if A is 10, and then you went 2 sine 10 cosine 10, you'd get the exact same number. That's how they got this double angle identity. All right, now, let's see how they got cosine of 2A. Cosine of 2A, they made it cosine of A plus A. It goes cosine A, cosine B, which is right now A, minus sine A, sine B. Now what happens, girls? Cosine times cosine of the same thing. Now they're multiplied. So it's cosine squared A minus sine squared A. Now what is cosine squared plus sine squared is 1. Cosine squared minus sine squared is equal to this, which is cosine 1. What's A plus A?
So it's 2A.
2A. So this is another identity you'll have to learn. However, I hardly ever use this one. I usually use it instead of this one, all right? Who can tell me what cosine squared is? That you already know something else about it. Cosine squared.
Plus sine squared equals 1.
Sine squared plus cosine squared equals 1.
So it's sine squared plus 1, sine squared minus 1.
Look at your identity and rearrange it mentally.
1 minus sine squared.
1 minus sine squared. Now what would you say? I would go, oh, well that's 1 minus 2 of those sine squares, like terms.
Yeah.
Or, as long as I'm doing that, couldn't we do this? We could go back to this statement, and I just changed cosine squared. Let's leave cosine squared alone and change sine squared. But be careful, I have to subtract the whole statement I'm about to put in. What is sine squared?
1 minus
1 minus cosine squared? You gotta be really careful here, those don't cancel. What's cosine squared minus a negative cosine squared? Is 2 cosine squared, isn't it? Aren't you adding? Okay. So you have 2 cosine squared minus 1. So what I would say to you is this is what you really get at first, but we usually use this form or this form. So it's a weird identity you're going to put on your memo page in a minute. You're going to list 3 things, okay? And I'll coach you through how to pick one, but it's one of the weird ones that you've got 3 things that give you the same answer, okay? But most of us we'll hardly ever pick this one actually, but you still need to memorize it when you run into it. And then tan 2A, I don't require that you learn, but we'll put it on your memo page, okay? If I ask you for tan 2A, guess what you can do? Put sine 2A over cosine 2A, all right? So here they are, the double angle identities. And I think, I'm not promising these may be our last identities, and so we'll add some other things to your memo page that have to do with trig. But this might be all of the identities that people memorize.
Oh.
Alright, so sine 2a is equal to 2 sine a cosine a. Cosine 2a is equal to cosine squared a minus sine squared a, which turns into 1 minus 2 sine squared a, or 2 cosine squared a minus 1. And tan 2a is derived the same way, but I don't require that you memorize it. Not that I wouldn't ask it, but if I do, I would put sine over cosine. Tan 2a is 2 tan a over 1 minus tangent squared a. So I don't know if that is too messy. So do y'all see what's kind of weird about cosine 2a? It has 3 facts that you need to learn about it. There are some of my students, girls, that only learn this one because they know how I got the other 2. But I suggest you learn, if you're gonna, that you learn them all.
Oh gosh, we're really cramped.
I just
Sorry.
I respaced all of my stuff.
Sorry, not sorry.
I'm gonna have to walk here. I'm remaking it, but when I remake it, it'll look nicer too, so it's fine.
Yeah, same.
I just am desperate. I wanna know this. It's not a big deal though, guys. I'm okay. I'll be so. This week,
This is the only thing you have to pay for. That's what it really seems like.
Such a
yeah,
tired
it is.
day.
Okay, so
Wait, that's cosine squared though, right?
cosine squared. Well, it's cosine 2a equals, this
Oh,
is,
that's 2a.
this is a, these are all right next to the a.
What is the is that CoA?
I don't know which one you're talking about.
The first one.
Cosine 2a equals cosine squared a minus sine squared a. This says right here, cosine
No,
2a
top.
equals
How
cosine,
about the sine 2a?
this is sine 2a is 2 sine a cosine a.
Cosine.
Maybe it's alright. I was over there. Same.
Alright, now let me show you what you're going to be doing for homework. And hopefully you've written them down because I need to go ahead and move to the last 3 minutes. You know where they are, if you hadn't got them, okay? Really need to move on.
She can copy mine.
Well, I need them listening, so I'd rather wait, thanks.
Mine's one.
I have the last one to write.
Okay.
Yeah, the last one's the easiest.
Okay, please.
So sine 2a, there's an implied parentheses between the two.
Wait,
and
next
sine
week
A
is
and
the long
cosine.
weekend.
Oh my god, the Oscars is this
Yeah.
Well, it's all multiplied together.
Yeah.
Alina,
I love watching
Alina,
that.
we have a full week next week,
Yeah,
and the
like
weekend
it's
we have
2
a 4-day
times sine
weekend,
A
and we have Monday.
cosine A.
No,
It's just
no,
two
no,
rows and
it's
rows
2
and
sine a
rows.
cosine.
Huh?
Like, you only distribute if there's
I
like
get a nice
plus sign.
5-day weekend.
And it's like 2 times 3 times
Really?
5.
Yeah.
Does that
I
make
just
sense?
like
Yeah.
watching the
Where are you
Oscar.
going?
I like having it on. And
I don't need y'all
Yeah.
talking, I need y'all paying attention. Alright, so this, look, have your memo page out and let me show you what you're gonna be doing for homework. I pulled it up here. Yours will be out of the book, but this is what you'll do, okay? You'll have your memo page out. It'll be on double angles, okay? And I'm gonna draw a triangle, and it says that secant is negative 13/5. I'm not a fan of secant. I'd rather use cosine. Cosine of x, if this is negative 13/5, wouldn't it be negative 5/13 using another identity? If I give you like a reciprocal, I'd rather use sine, cosine, or tangent myself. You'll draw a triangle. Now, if secant and cosine are negative, it's got to be either here or here. You'll draw a triangle. What does this say? It's not in quadrant 3. So it's not in quadrant 3, So where is this gonna have to be?
Quadrant
In quadrant two. It's kind of a weird way to say it. On a test, I would say it's in quadrant two, okay? Now, cosine is -5. Y'all see it's going back 5? The hypotenuse is 13. And how can you find the missing side? Pythagorean theorem. If you've been prepped for standardized test, it's a 5, 12, 13 triangle, okay? Or do the Pythagorean theorem. Be careful you get the sign right. Girls, listen. Draw a picture. Is that 12 positive or negative in the second quadrant? You've gone back 5. How are you gonna, isn't it positive 12? All right, now sine 2x is 2 sine x cosine x. I'm following the pattern on your sheet. Nazareth, this is what you were asking me. So you know cosine x is -5/13. And now from your picture, don't you know what sine of x is? Is 12/13. And this is over 1. So you'll be drawing some pictures and doing Pythagorean theorem to have all your pieces. What's that? 60, I think this is -120 over 13 times 13 times 1 is 169. Okay? Cosine 2x, I would use 2 cosine squared x minus 1. Because they gave me cosine x, -5/13 squared minus 1. So your homework's going to be mostly arithmetic. Draw a triangle, Pythagorean theorem, and then fill it into the formula. Tan 2x, I would just put sine 2x over cosine 2x. So while you're packing up, I'm going to finish this problem. You can leave. I'm just going to stand here talking to myself, and then I'll stop the video, okay? I might even do another example, all right? Oh, by the way, just in light of my most recent error, please be packing up, I'm sorry. I have already posted the homework, but it said quiz on fundamental identities, and I was gonna go over some more today, so that is not gonna happen. And when I update it, I'll put capital updated, so you'll know what your homework is, and I'll do that in the next 20 minutes, okay? So wait till it says updated, Kate, because she's first one to do her homework usually, okay?
I'll do it on Sunday.
Alright, okay, so I'm gonna keep talking to myself.
Thank you.
So this is 2 over 1 times 25 over 169 minus 1. That gives me 50 over 169 minus 1, which is 169 over 169.
No, it's just like this is the end of the season.
And so 50 minus 169 is 119, so you get -119 over 169. That's the answer to cosine 2x. And then tan 2x, I would go -120 over 169. That's sine, divided by cosine, which is -119 over 169. So I'm saying sine 2x over cosine 2x is tan 2x. A negative over a negative is a positive. When you do keep, change, flip, you get this. Oh, sorry. Thank you. All right, so another example. Bye, girls.
Thank you.
Let's see. Okay, another example. This one's in quadrant 1. Sine of x is 4/5. Pythagorean theorem would give me 3. I can see it's a positive 3. Sine 2x is 2 sine x cosine x. Sine of x is 4 over 5, and it's also given. Cosine of x is adjacent 3 over 5. This is 2 over 1. If you multiply that, it gives you 24/25. Now for cosine 2x, I have 3 choices. I'm choosing 1 minus 2 sine squared x because they gave me that one. So I'm going to say 1 minus 2 sine of x is 4/5 squared. Order of operation, that's 16/25. So I have 1 minus 32, this is a 1, 2 times 4/5 squared as 2 over 1 times 16 25ths, so that's 32 25ths. Get a common denominator, 25 25ths minus 32 25ths is negative 7 over 25. And so that's the answer to cosine 2x. Tangent 2x, I'm going to put sine 2x, 24 25ths, over cosine 2x, negative 7 25ths. And I'm going to do keep change flip and get negative 24 sevenths. Another example. This is sine of 2 over square root of 5. Alright, sine can be in quadrant 1 if it's positive, or in quadrant 2. It says it's not in quadrant 1, so I know I'm over here in quadrant 2. When I do the Pythagorean theorem, x squared plus y squared equals r squared, I get x squared is 1, so I have to decide if it's plus or minus 1. I can see in this picture, here's the missing side. Opposite is 2, hypotenuse is root 5, and I know x is 1, but I need to put in negative 1. And then you fill them in. Sine 2x is 2 sine x cosine x. Following your pattern. So sine x is 2 over root 5. Cosine of x is negative 1 over root 5. That'll give me negative 4 over 5. Square root of 5 times square root of 5. For cosine 2x, I would use 1 minus 2 sine squared x, because they gave me this. 1 minus 2 sine squared. So I have 1 minus 2, this will be 4 fifths. That gives me 1 minus 8 fifths. That gives me 5 fifths minus 8 fifths, which gives me negative 3 fifths. That's cosine 2x. And then for tan 2x, I'm going to put sine 2x over cosine 2x. And I'm going to get 4/3 for my answer when I do keep change flip. So one more thing to help you with your homework. On your homework, it might say something like this: your angle is between 0 and pi over 2. That's trying to tell you, here's pi over 2, it's in the first quadrant. If they tell you it's between 3 pi over 2 and 2 pi, here's 3 pi over 2, this is pi over 2, this is pi, 2 pi. So if they're telling you like this in radians, they're trying to tell you you're down here in quadrant 4, and so then draw your triangle in quadrant 4 with your pieces.